On June 10, 2018, Opportunity sent its final message to NASA. My battery is dead, and it's getting dark. NASA's Opportunity was then suddenly swallowed by a dust storm. NASA was pretty sure that because of that, its solar panels were broken and could no longer function. Then, in 2019, NASA sent its final message to Opportunity. I'll find you in the morning sun, and when the night is new, I'll be looking at the moon, but I'll be seeing you. A song titled I'll Be Seeing You by Billie Holiday. NASA then relayed to the world with a tweet that the rover had finally rested and thanked it for its service. To the robot who turned 90 days into 15 years of exploration, you were and are the opportunity of a lifetime. Rest well, rover. Your mission is complete. In 2003, NASA launched the Opportunity rover on a 90-day mission to explore Mars. Surpassing expectations, Opportunity traversed the Martian terrain for over 15 years, covering more than 45 kilometers. Throughout its journey, Opportunity achieved numerous milestones. It discovered compelling evidence of past water activity on Mars, including ancient channels, sedimentary rocks, and mineral formations. Additionally, Opportunity analyzed Martian rocks and soil composition, providing valuable insights into the planet's geological history. The rover conducted extensive geological surveys, identifying diverse features and formations across the Martian landscape. It also studied Martian meteorites and impact craters, contributing to our understanding of the planet's surface processes and history of bombardment. Moreover, Opportunity captured breathtaking images of the Martian surface, offering panoramic views and close-up snapshots of rock outcrops and landscapes. On May 30, 2018, NASA's Mars Reconnaissance Orbiter, MRO, first spotted a dust storm brewing on the Martian surface. Rapidly expanding, the storm enveloped a significant portion of the planet by June 12th. By June 19th, it had escalated into a planet-encircling dust event, colloquially referred to as a global dust storm, although these phenomena don't genuinely blanket the entire Martian globe. Due to the dust obstructing sunlight crucial for charging Opportunity's battery, scientific operations had to be put on hold. From June 10th onward, no signals have been received from Opportunity. And by February 3rd, 2019, NASA declared the Opportunity Mars rover dead, more than 8 months after the solar-powered robot went silent on the red planet during a raging dust storm, and a day after the final calls to wake Opportunity up went unanswered. When you gaze at the Martian landscape in photos, it might seem like a quiet, desolate world, nothing but a vast expanse of dust and rocks, accompanied by the faint whisper of the wind. But stick around, and you'll witness a colossal wall of swirling dust and sand brewing on the horizon. Mars once experienced a vastly different climate, a time when colossal dust storms weren't the norm. Forming around 4.5 billion years ago, Mars, our neighboring planet, has undergone remarkable climate shifts over time. Initially, boasting a dense atmosphere capable of sustaining liquid water, it has since become a barren wasteland with less than 1% of Earth's atmospheric density. This transformation was spurred by chemical changes within Mars's core, leading to the loss of its magnetic field and subsequently its oceans. In recent studies, Henri Samuel, a planetary dynamicist at Paris Cité University in France, suggests that Mars's core is composed of a denser layer of silicon-rich, molten rock and could act like a thermal insulator layer, preventing the core from cooling and solidifying. This, in turn, would help explain why Mars lacks a planetary magnetic field. Earth's magnetic field results from the way in which its solidifying inner core stirs up its outer liquid core, creating powerful electric currents that generate a magnetic field. The uniqueness of Earth's core allows it to generate a magnetic field that protects us from solar winds, allowing us to keep water. Mars's core does not generate this protective shield, and so the planet's surface conditions are hostile to life. Nicholas Schmer, co-author of the paper and associate professor of geology at the University of Maryland, added, "Then there's the colossal Hellas impact, a giant crater in its southern hemisphere. The Hellas impact basin, also known as Hellas planitia, emerged approximately 4 billion years ago as one of the largest impact craters in the solar system. It profoundly affects Mars's atmospheric circulation, acting as a heat trap during the day and potentially influencing wind patterns and dust lifting. Furthermore, the basin harbors substantial amounts of buried water ice, whose sublimation can contribute to atmospheric pressure changes, indirectly influencing dust lifting and weather dynamics. Mars's thin atmosphere leads to big temperature swings, from hot highs of 27 degrees Celsius, 81 degrees Fahrenheit, to freezing lows of minus 133 degrees Celsius, minus 207 degrees Fahrenheit. This drastic change creates strong winds as hot air rises and cold air sinks, sparking swirling dust devils and dust storms. Martian dust storms can reach a height of up to 20-30 kilometers or 12-18 miles. What's even scarier is that approximately every 3 Martian years or 5.5 Earth years, these storms escalate to what we call global dust storms. It starts with localized events like dust devils or regional storms, injecting fine particles into the atmosphere, which then get suspended and carried by prevailing winds across the planet's surface. Dust devils, swirling columns of dust lifted by Martian winds, play a significant role in this process. These mini-storms can reach staggering heights of 8.5 kilometers and 700 meters wide, lasting up to 25 minutes and traveling as far as 75 kilometers. They are particularly prevalent during the Martian spring and summer, when sunlight kisses the Martian soil, heating it up and causing nearby air to rise, while cooler atmospheric air swoops in to fill the gap. This tag team of winds crafts swirling columns, injecting fine-grained particles into the atmosphere. Mars's lighter gravity compared to Earth's also plays a crucial role in the dynamics of dust storms. Due to its lower gravity, Mars can sustain dust aloft for extended periods, allowing suspended particles to contribute to the atmospheric dust load and potentially leading to dust storms. Once airborne, Mars's lighter gravity keeps the dust up for weeks, even months. These particles act like mini heaters, soaking up sunlight and gradually releasing warmth into the nearby air. With the thin Martian atmosphere, dust becomes expert heat collectors, triggering a chain reaction. Warm air rises, drawing in more wind, prompting more dust to enter the atmosphere, creating a perfect storm. The process leading to these storms involves saltation, where Mars's dust particles, slightly electrostatic, require a push to get airborne. Larger sand grains catch wind easily but crash down, kicking up lighter dust into the air and turning into regional dust storms. Eventually, the accumulation of dust reaches a critical threshold, at which point atmospheric conditions become conducive to the initiation and propagation of a planet-wide dust storm. Factors such as increased solar heating, changes in atmospheric circulation patterns, and topographical features can all play a role in triggering and sustaining these massive storms. Once underway, global dust storms can persist for weeks or months, enveloping the entire planet in a thick haze and impacting surface visibility, temperature, and atmospheric dynamics. Larger storms typically only happen during the summer in Mars's southern hemisphere. Seasons on Mars are caused by the tilt of the planet, like on Earth. But Mars's orbit is less circular than Earth's. For part of a Martian year, the planet is closer to the Sun, and therefore significantly hotter. This warmer time is during the southern hemisphere's summer, so radiative heat forces are strongest then. Contrary to popular science fiction depictions, these storms lack the power to topple spacecraft or damage satellite dishes. With atmospheric pressure 100 times thinner than Earth's, Martian winds are slower. The Viking and Pathfinder observations showed that the wind speed on Mars is fairly weak, 1 to 4 meters per second, about 2 to 9 miles, or 4 to 15 kilometers per hour. However, under some extraordinary conditions, such as in the event of global or local dust storms, winds are expected to blow at speeds over 30 meters per second, about 67 miles or 110 kilometers per hour, sometimes even more. These global storms also obstruct sunlight and even generate lightning. As dust particles rub against each other, they produce an electrical charge. Unlike the tiny static charges generated by rubbing a balloon on your head, these dust particles can generate static charges on a massive scale. You can see this happening on Earth during volcanic eruptions, as dust and ashes rub on each other as they come out of the volcano's crater. Luckily, these storms are subdued due to Mars's thin atmosphere. But there are still challenges. Future colonists must think about the nature of the Martian dust storm, its possibility to infiltrate habitats, and its potential to damage equipment. Furthermore, Martian dust, like talcum powder, poses potential health hazards for human lungs, necessitating advanced filtration systems and protective measures to safeguard colonists' well-being. They would also have to think about what they would use as an energy resource. Solar panels, while efficient, may become unreliable during dust storms, covering the panels and significantly reducing energy production. Also, during regional storms, the aerosol optical depth, AOD, which measures the amount of sunlight dust blocks, can skyrocket to 3 to 5, lowering the amount of sunlight that enters the Mars surface. And during those global dust storms, the AOD can reach a staggering 9 to 11, making Mars almost completely dark. This means alternative energy sources like nuclear or wind power will be needed. Even rovers like Curiosity, equipped with nuclear batteries, face communication disruptions and must endure these storms. Rovers relying on solar power face dire consequences when electrostatic dust particles carried by these storms settle on their solar panels. The gradual deposition of dust obstructs sunlight, leading to the demise of several missions from Earth. Satellites aren't spared either, grappling with atmospheric expansion caused by copious amounts of dust. They navigate course corrections to counter atmospheric drag, a necessity to avoid plummeting from the Martian sky. For future settlers eyeing Mars, overcoming challenges is crucial. Settlements relying solely on solar power would struggle during storms, needing alternative energy sources. Surviving freezing temperatures and communication blackouts adds complexity. Self-sufficiency is vital, as seeking external help during storms might be impossible. Interestingly, these storms eventually fade away, cooling the surface. Without warm winds, they can't sustain themselves. Despite the challenges, Martian dust still holds immense potential. This dust reveals that Mars is not just a dusty world. Each particle can give clues to the planet's past climate and indications of potential resources such as sodium, potassium, chloride, and magnesium. The prospect of utilizing this abundant material for 3D-printed habitats alongside the extraction of valuable metals like iron and titanium holds promise for the development of a Martian society. On May 20th, 2022, we bid farewell to another Mars rover. China's Zhurong, like Opportunity, a solar-powered rover, succumbed to another dust storm. Landed on Mars on May 14, 2021, it was intended for only 90 days, but exceeded expectations and remained active for 347 days instead. However, on May 20th, 2022, Zhurong entered hibernation mode. The reduced sunlight because of the storm forced its operations to stop and is awaiting improved conditions to resume. Although hopes were high for its revival in December 2022 as winter subsided and sunlight returned, recent NASA images reveal Zhurong is still dormant, exactly where it entered hibernation almost a year earlier. The uncertainty surrounding its fate is palpable. As of January 2024, there are only 2 rovers left active on Mars exploration: NASA's Curiosity and Perseverance. On the other hand, NASA and the European Space Agency, ESA, are collaborating to bring back Martian samples for in-depth analysis with the Mars Sample Return Initiative. Perseverance is spearheading the collection efforts, while a sample retrieval lander, scheduled for launch in 2028, will retrieve these samples. Equipped with advanced technology such as a Mars rocket and helicopters, the lander will touch down near Perseverance's location within Jezero crater. Once loaded, it will embark on the journey back to Earth, expected to arrive in the early to mid-2030s. These samples hold immense scientific potential and are poised to unlock significant insights into Mars's mysteries. Exciting times lie ahead in the realm of Mars exploration. As we bring this exploration to a close, we invite you to stay tuned for more captivating insights into the cosmos on Science with Lou. Remember to subscribe and accompany us on our expedition through the marvels of space and science. Until next time, keep gazing upwards, for the universe never fails to astound us with its wonders. Thank you for joining us.